as he mentioned, I'm product manager for geophysics at Datamine. I don't want this to sound too pluggy or anything like that, so I will get on with the plug for PA first up, and then we'll get on to some of the data. So PA Explorer, it was Profile Analyst if you haven't, if you have used it in the past. It's been in hiatus for maybe the past 5 years, but we've worked on it for the last year or so, and we finally released a 64-bit application this year. That was in November, so I've been using it like mad, trying to get some great data into it, because 64-bit meant that it was able to work with quite large data sets, which the data I'm working with today is. We've updated some of the license management so you can self-manage and self-serve if you like. And we've also incorporated the read-write for ECW and ERDAS, which means you can incorporate some of these large JPEG 2000 or ECW images, which I did use in this particular instance as well. So you can import and export these in PA. So that's PA Explorer. So on to today's talk. So as Oleg mentioned, I will be covering the conductivity of the area displayed in your screen. It's a very large survey that the government, Geoscience Australia and the GSWA government acquired in August in 2000 as part of their initiative for exploring for the future. And it's been widely used by some of our clients, and probably a lot of them had a lot of frustration trying to bring that in. But I'll just show you how I work with it and what I do with it, and how I found some other data in this area as well. So TEMPEST is a non-invasive technique. It detects variations in conductivity to groundwater depths up to several hundred meters. The conductivity response is commonly caused by electrically conductive materials such as salt or saline waters or graphites or clays or sulfide minerals. In this instance, it's quite good for distinguishing the sedimentary cover to bedrock, to basement rock, especially considering this area has got some of the thickest cover of sediments, and it's been quite commonly used in Australia. So as I mentioned, this covers part of the Northern Territory and WA as well. So you can see I'm mainly dealing with the one that's covered in red, by the way, if you're looking. So the lines that are flown in that are displayed in red. It is very sparse, so 20-kilometre line spacing, because this area that we're talking about is large, so 55,000 line kilometres to be exact. So it's very, very sparse at places, but still quite useful. So if you look at the type of data that comes with this, it includes some of the DTM, and you can see I've got that here. You can see the coastal plain, and the variation is probably about 500 metres, so not too huge over such an area. But so yeah, Australia is quite flat, thankfully. We did have some magnetics as well that came with it. This particular one I've gridded in 5-kilometre cell size. It was, and really not a lot to distinguish this one between some of the sediments and some of the conductive materials. I did run a 1VD, so I'll just toggle between those two. You can see not a huge variation with 1VD as well. So it's very regional scale. So how I work with this data, initially I just brought this in and viewed it in profile views. So I'll just show you my workspace. This is called a template, and I just explain what I've got here. So on top, I've got my magnetic data, which we already saw in the previous slide. In a profile view, I've got some of the DTM. That's also was in the previous one. So in the middle one, there is the ZEM data for the Z channels, and you can see how that looks. I've just coloured that in, and it's got a bit of scale applied to it as well. So the middle one is also the CDI sections. So they are quite noisy at places, but some of them can show you some nice conductivity delineations. So I could look pretty good. And you'll see that in some of my videos. I've got the bottom image shows the location in red, and the image there is just from the geological survey. So that's just a map of the geology for that particular area. And you can see how the lines look across that whole area. Because this is on a template, all of this is linked. So you can see in my next one, which I made a video out of. I wanted to avoid doing a live demo at all cost, maybe one day. But you can see how it all looks when you flick through it. So it is all linked, and it's all nice and interactive. Some of the lines are quite short as well, so some are longer, and you can see how the conductivity changes, and you can see that some of it is quite distinct and some of it is quite noisy. So the CDI does have the elevation added to it, so an offset of that elevation as well, right there, so you can see. So that's just. So this data in line format is quite nice to be able to just look through it quickly and see if you can see any really quick anomalies. Another thing that you can do, so if you've seen anomalies, is choose some of those conductivity features, and that's what I did in my next step. So after I picked some areas of interest, I chose to create some features. So you can see the one in red there, and if I think I've just got quite a brief video. You can see how you can create these features. So these features go to a feature geodatabase, and then you can consume them in 2D as well, or 3D even. And I think I've got an example of that, how that works as well. So when you're looking for highly conductive substances, it's nice to be able to just quickly go through and flick and map these features. So these are all projected as well, like I said. And in the next image, I do have an example of how I have put them in my 3D view. So this one has got all those conductivity CDI sections that I displayed in my previous one. This is just the top Kimberley Plateau, so just that bit that was right at the top, and it's got all referenced CDIs that I've displayed in 3D. And once this is actually a great way to look at them, because you can do fly-throughs and various other ways to quickly flick through them as well, and you can see exactly where things are located and also which areas are more noisy, so you can also remove some of them. So I'll just show you what I did with the features after that. So the features that I created in the 2D sections, I could then bring into this 3D section. So as you can see, so they're all the feature geodatabase. You can edit these on the fly as well. So if you do adjust something on these in 3D, because you can edit in 3D, you can also, it will automatically change it into your feature database. Now that this looks a little bit rough, so this was just a quick wireframe, and I did this just for fun, basically, just a way to, because they're very far apart, and I didn't even do every single line, so that some of those are 25-30 kilometers apart, but it's still just an example of the kind of things you can do if you had sort of more high resolution data. And so that's all my CDIs, and I've also draped, so just on this one, I've also draped the geology on top. It's actually quite a bit faint there, but you can see how you can do it. So all those CDIs you can export to 3D automatically, which is, and they're actually a referenced ECW or a PNG file, so you can reuse them again as well. So rather than doing this on every single section, I also chose to create a 3D grid of this. So you can see how that looks. I mean, it's quite flat. It is 5,000 meters cell size again. And then I created a voxel of this with a 3D grid. Actually, it was quite a quick process. And I do show, and I've got an example of what it looks like when you actually cut through this and see what it looks like. So this is just basically thresholding to high conductivity, and you can export those sections that are already cut, or these threshold surfaces as well. They look quite nice in 2D if you don't want to go and select features, because the conductivity is quite prominent here. So if you don't want to select all of these features, you can just export these out and then display them as slices in your 2D, and it looks quite nice. And I've just done different methods of cutting this as well to display different sections, different areas. So you can include any kind of images in this as well if you had extra geology. Also, you can include another thing, which I ran out of time basically because there was some drill hole in this area, but it was quite messy, so I did run out of time trying to clean it up to include it in this project, but you can do that if you wanted to. Okay, so what do I use this for? I mean, it looks quite sparse and it's quite messy. Basically, our clients use this to select prospective areas. This area in the Kimberleys that I've got is very, very prospective for nickel and base metals, and also diamonds. So any of the large majors in Australia would have tenements in this area. I was lucky enough to then start looking through some of the other government data that was available, and I did find some higher resolution data. So the one that I've got displayed there is it's magnetic data, but it's at 400 meter line spacing, and that was also flown by Geoscience Australia and I think it was GTEC. And you can see how automatically that's made a huge difference in the underlying data resolution. In fact, I then have got another image of that, which is zoomed in, and you can see on top of that is a VTEM survey, which is 150 meter line spacing. So that was nice to find. And you can see that actual grid that's displayed still looks quite nice, even at 400 meters as well. So the area here, I do have some of the geology information. It's got sort of medium to high grade metamorphic sediments and volcanics, and all the intrusions. So you can see some of the intrusions in the middle. I don't think I've got a pointer here. You can see they're either a granitoid type intrusion or maybe layered ultramafics and mafics. And these mafics and ultramafics intrusions are basically the targets for this particular area because they do have potential for zinc and copper mineralization, which I guess the hope was the VTEM could delineate between some of the bedrock and some of the conductors in this instance. So my next step was to look through these a little bit more carefully. So what I generally do if I find some VTEM data like this is I import it and create some nice profiles. But if you want to visualize this quickly, a great way to do it is to grid the mid-time channels because they're the less noisy ones. So in this instance, I did and this is all B-field data. So I've gridded 11 to 25. I do have like a bit of a time lapse so you can see how it goes noisier as you go along. And then you can see where some of these conductors could be or what the conductive materials are in this area. So I just use my interactive gridding, which is quite nice in PA because you can clip it and you can automatically export it. You can also export this as multi-banded data if you didn't want to export it as separate. I did these as all separate and then I just created a GIF or a GIF. I'm not sure what people prefer to call it. And you can see how what the time lapse is and how it goes. So this was 11 to 25. There's 40 channels in here, by the way, if you're, so you can see how it just goes noisier as you get to 25. And I then kind of thought, oh, what can I use? Which one of these images will I use to create some possible targeting? And I think I used, I don't know, I think 11 or 12, maybe further along for some of this targeting. So yes, this little GIF with the grid flipper is quite nice as well. So you can export this out, and you can also, have delays and things like that. So it's quite nice. It's like a little movie. Okay, so my next instance, so I went back to my profiles as well. I created just a very simple template of a profile with my grid on top, and you can see the area there. You can see how I've created some little stars. So in this instance, I showed you how to create the features before in the 2D sense, and these are just points. So this is still a 2D feature, but they're created from in conjunction with my profile and my grid. So I basically just picked based on that. I did look at my magnetic as well at the same time. So just looked at some of these features. And I'll just show you that. It was quite a simple exercise with looking at some conductors here. So you can see that. So what I'm looking for is anything that's kind of flat or very pointy. There's no defined way with EM, whether you don't know how the conductor is going to be laid. So anything that was flat and some of the pointy features as well. And then if I show you, I think I've got in my next slide what the mag looked like. So you can see there was some of those magnetic intrusions as well that are obviously giving me, so right in the middle of that, there was some intrusives which are also giving me anomalies, but they were still not as high as some of the other conductors that we had there. So here we go. So what I've done just in this exercise was I've incorporated the data from the geological survey at the back, and you can see where so the conductor that I'm talking about was right in the middle of that survey. And then you can see where I've picked my other ones with the little stars, where I've picked some potential anomalies. And obviously not all of these are going to be anomalies. I will be doing some sort of 2.5 or 1D, I guess, even models of these to see, using my EM and using my magnetics to see which ones are great prospects. And just for interest, the bottom line you can see there is from the initial TEMPEST survey as well. So the black line that you can see right across the survey, because these are north, sort of trending north-south, but that was an east-west line. And I didn't actually even bother bringing that up because it actually does sort of go on some of my potential anomalies there, but I haven't incorporated that in this example fully. So that is what I did. So this basically didn't take me a very long time. It took me, the longest time was actually spent downloading the data from the government rather than presenting it in PA. So that was an interesting exercise in itself, because we have quite a few places where you can download data from. So my next step after this is, first I'm hoping to, well, maybe I'll get some more data. I do have some drill hole data, which I'm hoping to incorporate in here. Also, there is one very large seismic line that cuts this area as well that the government did, because this is close to a roadway, which I'm hoping to also incorporate. Some magnetotelluric, which is a bit harder to find as well, but I'll see if I can get some, and some passive seismic, and this is what I'm hoping to get in the end, I guess, if you say it. Just some real potential targets for this area. So yes, PA has got the option to incorporate any kind of being is that we partner with MapInfo. We've got the ability to import all of these drill holes, and also it does contain a SegWire reader. So I'm hoping to, when I get a bit more time, to incorporate some of that in my data. So just on this actual product itself, I'm also looking at better ways to work with passive seismic as well. I do have some passive seismic for a different area, and I realized about how many channels it actually has and what the time outlay is to QA/QC that data. So that's something that, as a product manager, I'd like to improve as well in PA. So that's it. Actually, very short and sweet, Oleg.